Good morning to everyone on the West Coast, good afternoon to everyone on the East Coast, and good evening to everyone joining us from Europe. Welcome to the Neo Technology webinar series. I'm your host, Adam Frankel. Today we're going to be talking about getting started with Neo4j with Andreas Kollegger, a senior consultant at Neo. So today's webinar will contain everything you need to know to actually get started and start working directly with Neo4j. Before we get started, I'd like to tell you that we're using the GoToWebinar software. Apparently there's some inconsistency between GoToWebinar and the Lion operating system, so we can't give you normal full screen mode today, but we will give you a view of Andreas' slides. On the right-hand part of your screen, we have a question and answer box. Please feel free to type your questions in at any time, and we have pauses in the presentation to ask for questions, and we will have time at the end of the presentation to ask for questions as well. If you're on Twitter, please use the hashtag Neo4j to enter your questions, and we'll be monitoring that as well. I already know what the most commonly asked question is going to be. It's, are you making a recording of this webinar? And the answer is yes, we are recording this webinar, and as soon as we upload the recording to YouTube, we will send a link out to everyone so you can access this recording within 24 hours. I'd now like to turn the podium over to Andreas Kollegger. Andreas, please take it away.
Adam, thank you so much for the introduction. I'm really happy to be here today and speaking with you all about my favorite topic, which is Neo4j. Now, the plan for today is roughly going to be that I'm going to go through some slides to explain a little bit things about what a graph database actually is. But as quickly as possible, we're going to get into kind of a workshop mode where we're actually going to start using Neo4j itself, and I'm going to give you a tour of like what you can do with it. So as Adam mentioned, I was having a little problems. I just made the lovely upgrade to macOS Lion, and so I'm having a little trouble with that. And so I'll be clicking through my slides, but also hopping around to a web browser. So let's go along for the ride. Okay. So as I just mentioned, the plan for today is first to start off with a Graph Database 101. Where I assume a lot of you are here because you already have heard about Neo4j and possibly heard about graph databases, but just to make sure that we're all on the same page and that you understand the terms that I'm using, I'm going to go through what we mean, what we, Neo4j, means by a graph database. I'll then quickly review some of the features that you get with Neo4j itself and some of the popular use cases that we're seeing people use out in the field. And after that, we're going to get down to actually using Neo4j itself and having some fun. Okay. I've only got two big rules for the webinar today, and these you must obey. First, if you're going to be tweeting, as Adam mentioned, please use the Neo4j hashtag. If you want to address me directly, I am @Kollegger, and please go ahead and interrupt me. As a graph person, having tangents is a fantastic thing. I love following different paths down a discussion. Okay. So with all of those preliminaries out of the way, we're going to get into doing Graph Database 101. This is going to be very elementary. I'm going to assume that you know nothing about graphs, and we're going to go through discussing what all the features are of a graph and like what it actually means to use a graph. So not just a graph, of course. Today we're talking about a graph database. And it's sort of unfortunate that often when I speak about this, when people first hear about a graph database, they're confused as to what that means. And the first thing that comes to people's minds is actually, oh, you mean a database specifically for storing charts and graphs, or a database for storing vector artwork? But of course, that's not what we mean. If you reach back to your comp sci days when you're first learning about data structures, what we're talking about when we say graph is that we mean the computer science term of a graph. It's the actual structure for storing data in a graph-like way. So this is the generic version of, if you remember, linked lists and, of course, tree structures. These are all the kind of specialized cases of having connected data, right? So in a graph, you could have a linked list if you want to. You could also have a tree. But to make it into a graph, rather than being strictly linear or being strictly a hierarchical structure, you can have connections between any of the data that's within your data. The data within your data? Yeah, I guess I said that. So the generalized thing for me, my point of reference when I try to explain why graphs are interesting, like why this is a worthwhile thing to have in a database itself, is to think that, like, for everybody who is here, at this webinar today, a relational database will be fantastic at doing things like telling you what everybody's average salary is, but it's going to be pretty bad if you ask it something like, well, among the people who showed up today, who's most likely to buy you a beer? A graph database does that extremely well. And for today, actually, the most likely person is me. So if I happen to see any of you in person, please feel free to walk up and I'd be happy to buy you a beer and talk some more about graphs. Okay. So we're going to move into some of the details about technically what actually is a graph. Again, this is slightly academic, but in the sort of computer science world, what we mean by graphs is that a graph is defined as a set of vertexes and edges, where edges are just a connection between two vertexes. Okay? So in the diagram that I've displayed here, you can sort of read your way around the bubbles and read sentences, right? So in my first sentence, I described that a graph records data in nodes. So in a graph database, when we don't really have records, we don't have columns and rows, the individual record that is in a graph database is called a node. Now, in addition to the nodes, as I just described, you have connections between nodes. In Neo4j, we call those relationships. So the second thing that a graph database stores is relationships. And what relationships essentially do, of course, to create data structures is that the relationships give an organization to your data. They actually effectively are the real-time schema of all the data that you're saving. Now, unique in Neo4j is that the kind of graph that we have, we refer to as a property graph, because both the nodes that you have in the graph and the relationships between those nodes can have properties. And by properties, I mean this is the standard kind of key value pair of, okay, I want nodes to have a key called name, and for instance, that name is going to be, well, me, Andreas. So that's the basics of what we mean by a graph, right? Okay. So great. So you have all this data in a graph database. It's stored in this really interesting structure that you've created. The classic thing about a database is that once you've got the data there, you actually want to run queries so that you can pull data back out. In graph terminology, when we talk about querying a graph, queries for a graph are expressed as a traversal. And a traversal is exactly what you might think it would be by just, by the term. A traversal is a way of traversing through the graph from starting at one node and then finding your way along paths to other nodes. So you're kind of navigating your way through the graph. So that's what I explained here in the first sentence, is that a traversal navigates a graph. The result of doing that sort of navigation through the graph is you get back a particular path that starts from wherever your traversal started and ends up, according to the criteria that you've defined, identifying other nodes along the way. You get those all back in a data structure that you could iterate over to look at the results that you have. So as the final point here explains, that traversal result, the paths that you get back, are ordered. So the paths are an ordering of nodes within your graph. Okay. So we're going to move on. An obvious point to quickly run into is it's all great to say that, like, traversals are a way to query a graph, and as I just said, it's you start with one node and you decide some criteria for how you want to look for other nodes from there. Well, how do you get that first node that you want to start from? In Neo4j, we have a facility for looking up nodes. We have named indexes that you can create, and the indexes effectively are a special case of doing a traversal. You could, if you wanted to, have all of your data modeled within the graph itself so that you can simply ask the graph, well, give me the node 0, which for Neo4j, that's our reference node. You could, from one node, create structures that will let you get to every other node within the graph. And if you have an entirely connected graph, all the nodes are available. Trying to find individual nodes as starting points is such a common need in all applications that we've specialized that operation And we use indexes to actually say, okay, for this set of nodes, I want to take the name property and put that into an index, so that if I want to get the node for Andreas, I can just ask the index for that, and I get that back directly. And then having gotten that index node, I can start traversal queries from there. So those elements, which, what did I say? There's not a whole lot involved. It's nodes, relationships, properties on each of those, and then indexes. All of that combined together creates a graph database. So a graph database manages a graph with related indexes. In Neo4j, we have a graph database that you can see here. The database part is bolded in Word, because we are very, very, very serious about having this be a legitimate database where if you save the data into it, you know that it's saved. So all mutating operations, all operations that do any kind of changes to the graph have to be performed within a transaction. So these are full, proper ACID transactions so that you know that your data is always secure. Because this isn't just a graph, it's not just something to have fun with and do analysis. It's a proper database. In addition to having these nice secure ACID transactions, you can run Neo4j in high availability mode, which means that you can actually run a cluster of Neo4j servers that work together to increase the throughput that you can get in reading data from the graph. In terms of like the size of graphs that you can create with Neo4j, the current limitations are that you can create up to 32 billion nodes, 32 billion relationships, and 64 billion properties. For the vast, vast majority of applications, that is way more than you possibly will need. Neo4j as a database can be accessed through a lovely REST API. We're going to take a slight closer look at that later on in the presentation, and actually run a couple examples about using that. Though, yes, of course, and I should mention that the 4j part of Neo4j is the telling sign that Neo4j actually is also available in a Java library, so that if you want to just, rather than running a separate server or a cluster of servers for running the database, you could have the database embedded in your application directly and use it in that way. That has some benefits because you can actually do slightly higher throughput because you're talking directly to the database and you don't have the network overhead. The downside, of course, is that it's a Java library. So if you're using Neo4j from other languages, this isn't necessarily a great way to go unless you have a language that is also available on the JVM. Options, of course, end up being Scala, JRuby, JPython. Any of those things work out just fine. Okay. Some other general features about Neo4j itself, and a little background history. Neo4j is stable. I mentioned earlier that we're very serious about it being a database. This has been in production operation 24/7 since about 2003. Active development has been going on since before then. It is a high-performance graph database. It's able to do millions of traversals per second on just kind of standard hardware. Multi-core, reasonable amount of memory, but nothing that's going to be breaking the bank to actually have a high-performance database at your disposal. Okay. So now I'm going to actually dive into a few different use cases. And the use cases that I'm going to describe, I'll do a quick overview of a lot of different options of what's appropriate for using a graph. And then I'll look at a couple of specific examples that are taken from sort of the most common of what we see people using out in the field. So as an overview, and certainly as a generalization, what are graphs good for? And graphs are fantastic whenever you have highly connected data. And the reality in today's modern web applications is that every application is highly connected. In fact, as we've seen from our perspective, all applications are only becoming more connected over time. That the connections between records is actually becoming more important, not more important, of course, but as important as the records themselves. So, for instance, if you are Facebook, if you're Twitter, if you're even if you're Amazon and you've got all this giant product database, it's as interesting to know like what else is related to your friends, for instance. You want to know who your friends are and who their friends are, who those influences are. And you also want to know, if you're looking at a particular product, well, what are the related products? And what are the related products that my friends like? All of those kinds of things make a lot of sense to do within a graph. As I've alluded to a little bit here, my first thing is actually that recommendation engines make great sense to have within a graph, because graphs very nicely accommodate highly connected data that is relevant for different contexts. So within the graph, you can easily combine both social data, what do my friends like, with location data. Well, what do my friends who are in this area recommend for a restaurant that I should go to? And then any other kind of parts of the domain that you want to combine, you can continue to elaborate on the number of connections you have that will result in better and better recommendations for your end users. Similar dynamics end up occurring if you're doing this in business intelligence, where rather than being concerned about the aggregate results of your business, you want to sort of follow along root cause analysis of, from a starting point within your business. Let me look what else is being affected by some dynamic that's going on. You can read through some of the other things that I have mentioned here. Social computing is very obvious. Geospatial is fantastic. MDM is master data management. I'll take a closer look at that in a slide or two. Systems management, all the rest of this. Each of these different topics are highly, highly connected data sets that if you were doing this in a traditional relational database, you would end up with these, and this is the typical telltale sign, I guess, that the people end up realizing, we should probably look at a graph. Is if you're doing this with a relational database, you end up with these queries that have multiple joins. And if you've got 5 or 6 joins and increasingly large data sets, the joins are going to become incredibly painful. And you realize, well, with all those joins going on, actually what we have ended up with is a graph-like structure. If you go ahead and move that into a graph, you'll suddenly have really great performance. Now, I'm going to take a brief look at what I mean by how much better is the performance versus a traditional relational database. So early on, we had done a sample performance test for trying to compare, for a similar data set, how would Neo4j compare to doing traditional relational database tables. So we created a social network, just a completely fabricated network of random people with random names, and we put about 1,000 people into the database. On average, each of the people in the database had 50 friend connections. And then we ran a super, super simple query that said, all right, for any 2 random people within this graph, see whether or not there's a path that I can get to, limited to 4 steps away. And for the performance test, of course, we let both databases actually work them up so that they could do whatever internal optimizations they wanted to. And then we ran this repeatedly to try to get some average times. Now, this is a little more dramatic when I can do the full slideshow and you can get the point by point here. But it's interesting to note that, of course, in the relational database, running that query takes about 2 seconds. Running it in Neo4j takes about 2 milliseconds. And even more fascinating is that if we increase the amount of data in the data set by an order of magnitude, a couple orders of magnitude, and continue to increase it, Neo4j still runs that query at 2 milliseconds. Now, when you first look at that, that seems like, I don't know, maybe that's because we're really clever about caching the queries or we've remembered what we've done before. But that's not the case. That's not what's going on here. What's interesting about a graph database and doing graph-like operations is that the graph doesn't care how much extra data you put into it. It doesn't matter if you have 1,000 people or 1,000,000 people. The query, starting from, in my sample graph here, from Emil and expanding out to his subgraph at a depth of 4, doesn't change. The complexity of his query only gets more complicated based on his local subgraph. So it doesn't matter if the larger graph has gotten just huge and got ginormous, because that doesn't affect how Emil's relationships are to his people. Now with a relational database, every record that you add makes the joins more painful and slows it down. And so you don't get the same kind of benefits of the optimizations that we've made within the graph database. This, of course, points to the general difference between relational and a graph database. And for any of you sort of comp sci theorists out there, you will notice that it's a very simple relationship between a relational database model and a graph database model, where it's a simple transform that in the relational model, it's optimized for tables of data and doing aggregate operations on sets. Within a graph database, you can represent exactly the same thing as in the relationship, in the relational model, but it's been optimized for the relationships between records. So a graph database is fantastic for hopping around the relationships between records, but a relational database is fantastic at doing the aggregate computations on sets of records. That's the fundamental difference. Yeah, and so that's what this table, of course, illustrates. All right, so let's move on and actually look at some specific use cases. I'd mentioned master data management earlier. Master data management is a sort of business level look at all the business entities and, like, what's going on in your company. This is here a highly simplified version of that, where there's somebody who had the owner of the corporation has a couple different accounts, and those accounts obviously result with different customers. Customers have purchases, etc. And with a graph, it's really easy to do ad hoc queries for finding out things like, if two salespeople have overlapping areas of influence in a geography, and there's some sales made there, how does the split actually happen for compensation? Or you can detect that there is that conflict between two salespeople who've actually managed to get contacts into the same organization, and they're competing for the same dollars. The graph makes it really easy to kind of manage all these complex relationships that exist within a business in a way that's hard to do well with a relational database. Similarly, network management is a great area for using a graph, particularly if what you want to do is that you want to be the next great cloud service, and you're interested in trying to manage a huge warehouse full of servers and power supplies, and maybe you've got machines all around the world, and your customers have their applications distributed around the machines around the world. And it's incredibly important, if you have that scenario, to quickly figure out if somebody in one of those warehouses trips over a cord and knocks out a power supply. Well, what's the result of that? Like, what applications go down? What do you have to do for failover management to actually move customers' applications around so that they have minimized downtime? In a graph, again, all those complex interrelationships can be very easily expressed, and so you can have sort of real-time response to what's going on in your network. Moving on, geospatial is an incredibly natural thing to do with a graph, because if you think about routing algorithms are, of course, well, operating along a graph. So what's interesting about this is that when you put a geospatial context within a graph, you have the actual routes there in the graph. You don't have to imagine, okay, based on some sort of image of a map, what are these 2 points, and like, how do I get from this point to that point? The points are actually physically connected to each other within the graph through the the relationship structures. So there's been a fantastic project actually out using OpenStreetMap data, something called Transport Dublin, that's gone and done this out there, and you can see the URL. You can later on. I would hope that you're not doing that right now. Go ahead and take a look at Transport Dublin, and that's a live example of actually using Neo4j for mapping data. Okay, so that was the overall preliminary introduction. Actually, I'll take a brief pause here, and Adam, I don't know if any questions have come in, but this is maybe a good time to get some clarifications if people are confused about what I've talked about so far.
Yeah.
We're about to switch over into actually doing some stuff.
We do have a great question, one question. How can we ensure the transactions are in sync with the database if we have a graph database on top of Oracle database?
Oh, well, that's interesting. So I guess I would have to know a little bit more about what you mean by that, but perhaps I should just clarify that for Neo4j, the graph database is not an abstraction on top of another database. The truth is that, like, early on in its history, it was that. It was simply a graph abstraction on top of other storage, but the performance of that was so poor that the engineering staff at the time decided to just do everything from scratch. And so Neo4j is a full database with we go right down to the bare metal. So we don't have an abstraction on top of Oracle or MySQL. We are the database itself. We go right down to custom structures on the file system, optimized for doing graph type operations.
Okay, that's the only question we have now. Let's continue.
Okay, great. Thank you, Adam. Okay, so to switch into the live action mode, we're going to go ahead and get the Neo4j Community Edition. If you guys want to play along while you're listening, what we're going to do is actually go out to neo4j.org, hit the big shiny download it now button, and I'll give you a few minutes to actually go ahead and do that right now and continue to speak. I've, of course, have taken the time, just like a cooking show, to already download Neo4j, so I don't have to wait. But in a few minutes, I'll go ahead and switch into just using the terminal, and we'll take a look at what you get when you get the download, and then we'll start to actually run some stuff. Okay, so if I was actually going to be downloading it, I would have first gone to neo4j.org, our beautiful website. This here is the shiny button I was referring to for the download now. It will download the Community Edition. Neo4j is available in 3 versions. We have the Community Edition, which is the base level server, which has all the functionality for storing tons and tons of data and all the algorithms you could possibly want. In addition to that, we have what we're calling the Advanced and then the Enterprise Editions. They layer on top of the base server additional functionality for doing things like monitoring and also for making high availability clusters possible. For today, and for most purposes, certainly, when you're just getting started, using the Community Edition is fantastic. So hit the big download button, get that downloaded, and then we're going to take a look inside of it. And I'll try to take my time a little bit here. Whoops, that's not what I want. Wrong window entirely. That's the window I want. Okay. So I'm going to take my time just for a second here to give people a chance to download things, actually looking at the download and seeing what it's like. If you haven't noticed, I'm currently running Mac OS, so this will be a little bit different for some of you if you're using Windows, but I'll describe what those differences are as we go along. If you're on the Mac or if you're on any of the variations of Unix, any kind of Linux distribution, you will get something that looks, like this here after you do the download. So I'm going to go ahead and just expand that. It's a tar ball, so I'm just going to tar, extract it. And why I did that verbosely, I don't know, because it looks like lots of things are happening. Okay. So after having done that, we've got the Neo4j community folder. I'm going to change into there and take a quick look at what we have. As all good software downloads, a few things that are always worth taking a look at is this README text here. Actually has a nice quick orientation for what you just downloaded. We've tried to be mindful about putting helpful READMEs throughout the directories so that if you're on the command line and you're poking around in Neo4j, always look for readme.txt, and that will give you some hint about what's going on in a particular directory. Also, this upgrade text is worth reading. Depending on which version of Neo4j you have, and if you've had a previous version, of course, this will give you helpful information for knowing how to do any kind of upgrades that might be necessary. The rest of these directories, are pretty obvious, actually, what their roles are. Now, I'm going to switch for a second back to advancing a slide here. Yes, for the benefit of people who happen to be paying attention along, or might be looking at the slide deck, let's take a look at each of these directories and see what's inside. So the bin directory, of course, is what has the binary executables for actually running the server. It also has some associated tools that are available, like the Neo4j shell. In the configuration directory, this is conf, short for configuration. This is where you would do things like tuning the server itself, changing some of the startup parameters. We're not going to get into some of those details today. That's all well documented on the website. Actually, our Neo4j manual has lots of good information about that. Where is my manual page? Well, I'm not going to look for the manual. So in our manual, there's actually nice information about what the configuration parameters are. You'll notice that there's the data directory, which, as you could guess, is where the actual data will end up. You can see that it's currently empty, other than it has a subdirectory for log files. But after we start up the server, we'll see a GraphDB folder there, and later on we'll take a look at that. There's the doc directory that has some handy text files in there, and it also has the aforementioned Neo4j manual, both in PDF and HTML forms. You have that available offline, in addition to being able to read that on the web. There is then, of course, our lovely Java examples directory that has examples for both running Neo4j in embedded mode and for running it as a standalone server. In just a little while, we'll be taking a closer look at actually all the stuff in there. That's some kind of fun things. If you happen to be using Neo4j in an embedded mode, what you want is all of the contents of the lib directory. So if you're building a standalone application, all the stuff that's in lib are the jar files that you should be including in your standalone Java application. If you've got all that, then you basically have all of Neo4j ready to go. After the lib directory, there is, of course, our plugins directory. Plugins are an interesting beast. Plugins are a way to customize the operation of the server. You can extend some of the functionality and sort of do some special things with plugins. We're not going to get into the details today. We'll probably have a future seminar talking specifically about writing plugins. Thinking about that from the perspective of like traditional databases, it's best to sort of assume that, like, you know, writing a plugin is the equivalent of creating stored procedures on a relational database. Then we have, of course, the system directory that has all kinds of scary stuff that, you know, we have no reason to look at today. Okay. So that's where you just got it in the download. Hopefully everybody is downloaded it already if you want to be playing along with us. If not, I apologize, and hopefully you can quickly catch up. All we're going to do next, though, is simply run Neo4j. If you're on a Unix, all you have to do is from this directory that I was in, the top-level directory, just do bin Neo4j, and we're going to do console to get all of the output to come, well, to the console. So you'll see a bunch of messages come up, as they are right there. If you're on Windows, you should have a neo4j.bat file available. Just go ahead and double-click that, and that will also run Neo4j in console mode. At the end of the messages, you'll see, depending on your platform, some variation on a URL that says, you know, HTTP, some machine name, and then the port 4747. That's the default port that Neo4j runs on for providing both a REST API and also a web administration. Now, what's exciting about that is that it's the web administration that we're going to take a look at next, because with just using that, you can do a lot of fun things with Neo4j. Oh, and I'm just going to create a new window here for it. So this happens to be my beloved fatty MacBook laptop here, so the address is a little strange. But I go ahead and go to that address, and it redirects me to the web admin. You can see the web admin subdirectory that I just pointed me to. The web administration is exactly that. It's the administration for the database. It has a couple different panels with different features that you can use. Here on the dashboard, you get a general overview about what's going on in the server. You see, obviously, right here, a timeline that has eventually all the different counts of nodes and properties and relationships that are stored on the server. Also, a quick summary of like the current state up here. And you can change the time scale that you want to look at. I'm going to bump that down to 30 minutes so that hopefully we actually catch some data that we can take a look. Helpful to notice as well is that the kernel version is displayed on the dashboard on the overview, so that if you're talking to us either on the community site, either through the mailing list or through our web forums, or maybe directly to one of us through Twitter or something, it's always helpful to know exactly what version of the kernel that you're running, and that's displayed conveniently there as well. I'm going to hop back to my slides for a second to make sure that I'm sort of in sync. So yeah, we're going to go through each of the different panels that are available in WebAdmin and explain what they are, and so start actually doing some stuff with it. So the dashboard, as we've just seen, is the overview of using Neo4j from the web administration. Our next panel that's interesting is the data browser itself. Now, the data browser is a really fun interface for actually manipulating your graph. It's not just it's for browsing, but it's also for creating data within the graph. So if you didn't do any coding whatsoever, you could actually usefully create graphs from here and then actually look at them. So we're going to start doing that now. I think my next slide actually describes that in detail. So we're going to go through these steps. we can take a quick look to see what I'm about to do. We're going to add some nodes, and you'll notice that there's incrementing numbers as we add each of the nodes, and that there's REST URL for each of those. Then I'm going to add some relationships. So from the web admin itself, here's the node button, and I'm just going to click it a couple times. And so I've created, a couple extra nodes. That was as easy as possible. So if we go back to the dashboard, we'll notice that we now have 6 nodes in the graph. Worth noting, of course, is that when we were here in the data browser, the last node that we created was node 5, but we've got 6 nodes in the graph. The node 0 is always available when you create a new graph, and node 0 is what we call our reference node. It's the node that if you were going to create a completely connected graph, that is always available and is the starting point for doing traversals through a connected graph. Okay, so we've created a bunch of nodes, but they're not connected yet. To connect them, we'll then have to go ahead and add some relationships. We'll just click the relationship button, a little plus there. It defaults to the current node that we were looking at, which is node 5. And in place of the related to, I'm going to create a relationship called nodes. And I'm going to say that node 5, there's a relationship from there to node 0. Okay, great. Then I'm going to switch to node 4 by just deleting that, putting 4 into the browser search bar, and then you'll see that I'm at node 4. And I'll add a relationship for it. I'll do the same thing, make it go to node 0. And the web admin knows that I've already created a nodes relationship, so it lets me just pick that. And I'm going to go through and do that for each of the nodes that I just created, just add relationships to them. So we'll basically be creating a simple little graph that, of course, is just a one-level tree, but it's useful enough to actually demonstrate some interesting graph operations that we can do. So there's node 3 connected. Oops, I don't want that yet. I actually want to go to node 2, and we'll go from node 2 and have it go to node 0. Great. Well, I should have noted, of course, as we're creating these relationships, the data browser updates for displaying information about that relationship. So for instance, it just created that a node 2 knows node 0. Okay, so I think I have one more to do. Go to node 1 and create a relationship for it as well. So now we have a fully connected graph. Fantastic. If we go back to the dashboard, we'll notice that we have one relationship type that's been created. We've got 5 different relationships. Each of the 5 extra nodes I created, all going back to node 0, but we don't have any properties yet. Let's go back into the browser and actually add some properties to each of those nodes. So let's go back to node 0, and let's add a property for it. I'm going to add a property called name, and I'm going to make myself node 0. I think you should make yourselves node 0. Yeah, okay, and so if you just create the property and then hit return, that should get automatically saved. You can go to a different node then and do the same thing. So I'm going to go ahead and, oh, Adam, I'm going to include you in here as well, because I know you're around. I'd hate to not include you in my social graph. Node 2, let's add a relationship there. Adam, who else is on the call? Who can I add here?
Let's add Vikram and Donovan.
Vikram, you've been added to my social graph. And we're going to say that node 3, the name is Donovan, you said? Donovan, I hope I just spelled that right.
Yes.
Okay. Okay. And, oh, well, add my good friend Emil. He's always nice to have in my graph as well. And I think node 5 was the last one that I created. Oh, and we're just going to call that Bob. Okay. So I've effectively just created a small social graph. If we go to any of these nodes, we can see the properties that were created on those nodes. Actually, I should switch more slowly. I'm sorry about any kind of lag that I'm not taking into account in the webinar. But for instance, right, going to node 0, we'll see that the name is Andreas. Node 1 was Adam that I created, right? So we have this nice little graph. Go back to the dashboard. We can now see that so we've got 6 properties, that makes sense, the 5 relationships, and of course, only 1 relationship type so far. Fantastic. We've just created a super simple social graph. What's fun about the data browser is that while this interface is very useful for just creating the data itself, it's nicer to actually look at it by clicking this funny button over here. This toggles into the visualization mode. And from the visualization mode, you can see that because I was on node 1, it automatically focused on node 1, and it has the relationship from node 1 to back to me, to Andreas. Now I clicked on Andreas, which was gray. By clicking on it, it then expanded the subgraph that we're looking at to include the other nodes that Andreas is connected to. So this graph visualization is a very kind of elaborative way to kind of look through the graph. Rather than automatically showing you all the data that's available in the graph, which for very large data sets is hard to look at and sort of a big jumble of connections and nodes, we take an explorative approach where you start with the focus points and then you add places that you want to look at by clicking on the nodes from there. So this is a simple graph that's of only depth 1, but there's our little social graph, all these people that know me. And that's fantastic. This gives us enough to actually explore some more things. So now that we have our social graph, we're going to hop on over to the power tool, our console for querying the graph. Let me go back to the slides for a second because this is actually worth having a little bit of text that you can take a look at. This is what we had just gone through. We had just used the data browser to add some properties to our simple social graph, and here at the end, we finally took a look at the visualization of that graph. Now, the little visualization is nice. We can explore our way through that, but if we want to do interesting queries, you can't really do that with the visualization. That's when we go into the web admin console. In the console, we can use a couple different approaches for interrogating the graph data that's there. So we have Gremlin, which is a graph scripting language that can do queries as well. It can also do graph manipulations. And we've just added Cypher, which is a very SQL-like querying language. And you can also do raw HTTP. I'd mentioned earlier on in the slides that the Neo4j server API is a REST API. It's a very pedantic REST API, which means that it's very discoverable. It has very disciplined endpoints and how you manipulate from one endpoint to another endpoint. And we'll take a quick look at how to actually use that for accessing the graph. What's great about the console, the HTTP console particularly, is that if you're using this from languages that don't already have a nice client library available and you're writing your own HTTP requests, you can use the console to just try all those requests out and see what the results look like, and then update your code. So it's a nice kind of debugging tool, learning tool. First, though, we're going to take a look at Gremlin. Now, Gremlin is a graph scripting DSL. It actually originates from another project that we have a great relationship with called the TinkerPop project. A great guy named Marco Rodriguez, who's a brilliant graph theorist, designed the entire TinkerPop stack, and we've adopted his Gremlin scripting language to be part of the offering of Neo4j. So as it says here in the try it out section, we're about to go ahead and do that. We're going to hop over to the console, and we're going to run each of these queries to see how that looks like from the web admin. Okay, so I'm here in the power tool, the console. You can see our happy little gremlin there at the top as we've entered in. And over here to the left, it's always worth popping open for reference. There's a cheat sheet. You could just follow through the cheat sheet if you wanted to, and these are all sort of easily executable code. With Gremlin, you always have at least one variable to start with, which is G. G is the graph itself. Now, an interesting thing about Gremlin is that Gremlin is really a DSL that is composed within Groovy, so that not only can you do just the Gremlin keyworded sort of script things themselves, but because it's in Groovy, you can do normal Groovy operations. That comes into play when you're doing more advanced algorithms within a Gremlin query. For now, we're going to do some kind of simple things. So we have the basic graph, and we can get what in Gremlin terms is the vertex number 0. So there's v0. That's just our reference node. That doesn't look too exciting. But if we go to v0, we know that it has a name, so we can take a look at that. And the name is, of course, Andreas. From vertex 0, we also know that it has edges coming into it, right? So we can take a look at the in edges from vertex 0. And you can see that here's all the other edges, and then, at edge number 4 has a nose relationship to 0. Edge number 3 for node 2 has a relationship to node 0, right? That's all pretty good. We can also, of course, start at some other place. So we can go v1 and get its out edges. Now that, of course, has only one out edge because we just have the simple, one-level hierarchy of friends. And node 1 knows node 0. Okay. We could also, instead of the edges, get just a shortcut to the node that's attached on the out from vertex 1, and we can get the name of that. So we know that that's, of course, going to end up being Andreas because everybody has an out edge to me, and my name, of course, if you haven't remembered, is Andreas. So there it is. Fun things to step past that is that from vertex 1, we can go the out edges, and we can be particular about that. We can say, well, we want to find, go out the edges where the labels, label equals, I think I said nose, right? Yeah. So if you happen to have a graph that was more elaborate, you could, with this construct here, this is just a small closure that's being passed to the out E. So with that, you always get an it variable, and you can use that to filter the relationships that you're interested in. So if you had multiple relationships from a particular vertex, you could say, well, I only want the outgoing nose relationships. Here, of course, it ends up being the same as getting all of the relationships because we only have the one type. To take that a step further, we can go to the out edges. Actually, we'll take the shortcut of going to out, which we know will go to the top level. And then from that, we can go and take a look at the out edges from that again. Oh, wait, did I do that wrong? Out. No, I need to do the out edges and the in vertex. And then from that, do the incoming edges. Right, okay. So that's the super verbose way of getting the same result we've gotten earlier, but starting from node 1. Now if we take that just one more step, we end up now getting what is effectively the friends of a friend relationship. So we've stepped out across one relationship, and then from the vertex that ended out at, we went all the relationships coming into that, and so that's 2 steps away of node relationships. So from vertex 1, these are all people who vertex 1 knows, and then all the people that vertex 1, that person knows. So it's a 2-level traversal out. Gremlin has lots of other things that it can do. If you want to learn more about it, there's this web address here, which if I highlight it, makes it impossible to read. But there's a GitHub site for Tinkerpop, and if you look in the Gremlin section, it reveals a lot more about the syntax and like all the kinds of fun things you can do. Okay, so that's just Gremlin. Let's take a quick look at Cypher as well. Cypher, as I mentioned, is a SQL-like query language. It takes the approach of pattern matching for looking in the graph. To try it out looking at these examples here, it's slightly more verbose than Gremlin is, but it's also very, in our perspective, sort of very humane. It's very readable, so that you can just read this like a sentence and figure out what it's supposed to do. If you want to start at some node that we're going to call A, and we want that to be, index 0, the node 0, we want to return A, so that's going to get node 0. Similarly to what we had just done with Gremlin, we can start with A where it's index 1, but now we want to match from A through some other relationship to a node B, and then get that. So let's actually give that a try. From the web admin, we're going to hop over to the Cypher panel, and we're going to first start with that simple example where start A is node 0, and that we want to return A. And it'll return that node and the properties that are available on that node. Of course, it's Andreas. We can do the start where A equals 1, 1, and we want to match from A, and I'm just going to do the shortcut here of just any relationship out to B, and then return B. And that, of course, still gets me, because that was a different node that we started with, A1. To do the extra step then, of course, the friends of a friend, and this, if you look at just this part here, it's really obvious what that means, right? So if you think about that in terms of a sort of pattern matching way, it looks like a little graph. It's this little node A, and then some relationship, and then this node B, and then some relationship, and then node C. And from that, we want to return C. And as you would expect, that starts from A, hops up to the reference node, and then gets all the ones that the reference node knows, and returns that set of nodes. And of course, it's Vikram, Donovan, Emil, and Bob. Oh, and I'm sorry, we started at Adam. Cypher treats the queries a little bit differently than Gremlin does. Cypher, by default, filters out your start node, because it knows that you already have a reference to that node, you already know it. So it doesn't return that as the set unless you ask for it. So if we wanted, see, I don't remember, is it just C? Yeah. So if we want to include A in the things that are being returned, we can include it in this way, and then we'd say, okay, well, node A Adam ends up at Vikram, node A Adam ends up at Donovan, and we've ignored the in-between node, which is me, Andreas. We could, of course, see the full paths by saying A, B, and C, and then we would see that the queries that was run started at Adam, went through Andreas, ended up at Vikram. Adam, Andreas, Donovan, so forth, right? As you can see, this is a really great way to query the graph. There's a cheat sheet here if you forget about how to do some of the basics. And if you look in the Neo4j manual, we have a whole section that explains all the different things you can do with Cypher. Cypher, both Gremlin and Cypher are continuously evolving, adding great new features and getting more capabilities. It's a fun way to actually take a look at the graph. Okay. We've got a little bit more time here, and I do want to leave some time for questions, but we're going to take a quick peek at using the HTTP console. As I promised, this is a great way if you're doing raw REST API calls to the graph. This is what you want to start using. Again, for posterity, I'm just going to take a quick glance over at the slide I had for that. The HTTP console, it's a playground for using the REST API. When you try it out, you will see exactly the kinds of responses you're going to get from the server, and you can test things out and then adopt that for your code. The details, of course, are available on the Neo4j manual. Let's go ahead and do some of that trying out. This is just as if you were just executing raw HTTP requests with no extra setup or having to worry about anything. Let's just get the root. If we get root, we get a 200 back. It's all positive. That's great. And in true REST proper discovery mode, when we get the root, it explains to us, well, here's the other things that you can look at. You can also look at this endpoint for DB data, which is the endpoint for actually getting data out of the database. And then there's this management endpoint, which is what behind the scenes this whole web UI is talking to the database through. So that has some extra features. We're going to take a closer look at DB data, though. So if we get DB data itself, it shows us where to look for a relationship index, where to look for nodes, where to look for relationship types, what extensions are currently being used. As always, it has a way to quickly find out where's the reference node, and it explains that we currently have 2 extensions that are available. For both Gremlin and for Cypher, you can run them through the console here to actually just execute queries, or particularly with Gremlin, it's interesting to run the query on the server side as if it were running on the JVM there directly, and you can pass an entire Gremlin query across to the server and do things like, actually, let's see, oh no, the example isn't included, I think. One of the fun things you can do with Gremlin is that you can import data sets. Like if you have a GraphML data set somewhere, you could send across a Gremlin query that says, okay, initialize the database by importing this GraphML, stuff like that. So that's why we've included both the Cypher and the Gremlin plugin by default when you download Neo4j. We're going to take a quick look at accessing nodes. If we look at DB data, as it says here, node 0 is right there. DB data node 0, look at the reference node, You can look at the outgoing relationships. But of course, this doesn't have any outgoing relationships. It does have incoming relationships, and it explains that the endpoint for getting incoming relationships is that long thing. So DB data node 0 relationships, and then in will show us all the incoming relationships. Quickly, we see this is the raw data that you would get back if you were accessing through REST, and you can see all the information about each of the nodes that we created that, as expected, these are nodes relationships from, for instance, this first one starts at node 1, and then because we're asking about node 0, the 2 is, of course, node 0. Node 2, node 3, node 4, node 5. So each of the relationships that we've collected is returned here as JSON objects. Really easy to parse. And again, if you don't have a client library for your language, it's easy to use this directly to actually do stuff with the graph. We're coming close to running out of time for the hour here, so I do want to take a pause here to actually ask if people have some specific questions that we'd like to explore. Otherwise, I could go on, look at the Neo4j shell. There's lots of other stuff.
Okay, so we have a bunch of questions right now, so I'm going to ask Andreas to address a few of them. If we don't get to your question today, don't give up hope. We have a very active discussion group available on the neo4j.org website, so please feel free to go there and to ask your question in the discussion forums. But let's start off with some questions here. How does clustering handle simultaneous writes?
So, everything happens through a transaction, and the way the cluster is set up, that it's a master-slave replication scenario. So you can write to any server within the cluster, but the master is always controlled the write lock. So if there are multiple transactions going on, you have to wait for another transaction to complete, resolve that transaction, and then you can actually do a transaction. So writing is still essentially serialized through a single master. So you don't get an advantage of write throughput with the cluster. What you do get the advantage of is high read throughput. Reading is, of course, the much more common operation in an active database application.
Okay, next important question is, what's the difference between the milestone versus the stable version, and which is the GA version?
So with Neo4j, we continue to do active development and release code along the way in milestones. So our milestones are typically at 2-week intervals, and we try to focus very specific incremental additions to the server that we do full quality testing on, and then release that as a milestone. Now, the GA releases, the general availability, are the stable releases of Neo4j. So after we have accumulated a few milestones along the path towards a full feature set that we want to release, that becomes a full GA release. And for instance, it's currently available as 1.4, although I think we're very close to actually just releasing a 1.41. So there's a small maintenance update that's about to go out.
Okay, another question. How hard is it to embed Neo4j in an Android app? Do we have any experience with that?
Yeah, so we don't, well, I'm sorry, we do directly have some experience with that. One of our engineers has spent some lab time having fun with that, and I know that there's people out in the community who are actively trying to do that. It works, but it's not super high performance. The Android app environment doesn't have a great file system, and I think that's the trickiest part of actually getting good performance of Neo4j in Android. That's a good thing to ask the community list about, because I know there's people out there who've been doing that work, but I don't recall their names off the top of my head.
Okay, another question. How do I run a web admin using the high availability version?
So sure, with high availability, each of the servers that you fire up will have a web admin panel that's available. And let me jump back to the panel for a second. What will be different when you run it in high availability mode is that if you go to the server info page here, there will be extra information about whether or not that server is currently running as a master, or if it's a slave, and if it's a slave, which slave number it is, that kind of thing. But each of the servers in the cluster will have the web admin panel available to them. So you can look at each of the, your entire cluster, you can look at them individually and figure out what's going on this particular server. It's a nice way to actually track down if there are some problems going on, maybe from network connectivity or who knows what. It's not just one web administration for the whole cluster. Each of the whole cluster has web administration.
Okay. We have a few more questions. I think I'm just going to pick out one or two of them. But I encourage you, if I don't ask your question, hey, go on the discussion forums and ask them, because that way you can address your question to the whole community, and they're very welcoming of people asking questions. There was another question of, is it possible to specify relationships between relationships? For example, saying that knows relationship is like recognizing, so the query returns from both knows and recognizes.
Yeah, that's interesting. So no, there's not at the moment. In the current model, while relationships do have a type, it's not like it's a full type system where you have any notion of hierarchy or anything between the types of relationships. So when we say a relationship type, it's really just a shorthand for groups of relationships that have a common name. It's not a proper type system in that way.
Okay. And one more, and then we'll let Andreas finish up, is that can you show an example for multi-relationship? I assume that means that if you have two nodes that have multiple relationships between the same two nodes.
Oh, sure. Okay. So that's one of the things, like in the web browser right now, that's maybe not the most graceful thing, is that, whoops, there we go. Okay. So for instance, we know that I'd already created, let's show the relationships, that I'd created relationships between all of these nodes in node 0. Let's go ahead and just add a new relationship here from node 1 to node 0, and we'll call it a this works relationship. Okay, and so now if we look at node 0 and show the relationships, it has all these relationships individually, and you can see that for node 1, it has both the this works and the knows relationship. So if we obviously go to node 1, show relationships, we can see that it has both of those established, right, to node 0. The one weakness now of the visualization is that you'll only see one of those relationships to the node. We're looking at different ways to actually visualize this in a useful way that you can sort of select from the visualization what relationships are being shown, or showing each of them. It obviously gets a little bit more complicated because you can't use straight lines anymore, so you have to figure out a nice way to display that still kind of works.
Okay, there are a few more questions, but I'm going to let Andreas wrap up as we've already run over time.
Yeah, thank you everybody for showing up today. I know this has been kind of a whirlwind tour of all the basics. I'm going to very quickly just point out that what's available within Neo4j is obviously all we've just seen in sort of the operations side. If you're doing coding, go take a look at Spring Data Graph. It's a great way of actually using Neo4j from Java. If you're embedding it, we have this great native API. But you can also use it from Ruby on Rails. And if you just do some searches out on the internet, or just go to neo4j.org, you can probably find great data bindings for your language of choice and learn more about it. In the future, we'll have some webinars about using Neo4j from specific languages, but I hope that you've learned something about how to actually get started with Neo4j from the webinar today. And thank you, everybody, for coming by.
Thank you very much, Andreas, for a great hour. I also want to thank our audience, the vast majority of which have stayed with us for the entire hour. Your time is valuable, and I appreciate your giving us the attention this morning. If you have a question I didn't get to today, please go to our forums and post it. If you think of a question that you didn't have time to think of during the webinar, go to our forums and post it. If you think of a topic for a webinar that you'd like to see, go to our forums and post it. We all read that, and we would be delighted to customize our future webinars to be what people are interested in. Our next webinar is coming up in 3 weeks. We have a webinar on the introduction to graph databases. We talk about how graph databases fit into the greater scheme of NoSQL databases. So thank you very much, Andreas, and thank you, everyone. Thank you for all of our audience, and we hope you've enjoyed the webinar today. For those of you who joined after the first minute, we are making a recording of today's webinar, and as soon as we upload the recording to our servers, I will send a link out to everyone so that you can watch this again for your entertainment. Bye-bye now.